So the big picture for this lesson is linear inequalities, and that's inequalities with two variables. So I think the best way to explain this is to use an example. Let's say you're at a store and they sell hats for $20 and gloves for $10, and you have $100 total. So how can you represent the different combinations that you could buy of each one with your $100? I mean, you could make a long list, but you could also use an inequality. I'm going to use H for the number of hats you buy, G, the number of gloves you buy. So if hats are $20 each, to get the total amount of money you can spend on hats, $20 times H, so 20H. And then $10 for gloves, same idea applies, plus 10G. That is the total amount of money you can spend on hats plus the total amount of money you spend on gloves. Now, you have $100 total, so the amount of money you spend on those must be less than or equal to $100. Nobody's saying you have to spend all the $100, but you can't spend more than the $100. Okay, so how is this helpful? Well, what you can do is you can make a graph to represent all the different possible values. So the way you graph these is you graph the line that it represents, and then you do some shading. So I'm going to say this is the H for hats, and this is the G for gloves. So this is in standard form. Let's graph 20H plus 10G equals 100. So I need to find each intercept. So if I put 0 for G, I get 20H equals 100. Divide by 20, so H equals 5. That means there's going to be an intercept right there, H equals 5. Let's do the same thing with the gloves. Put in a 0 for the H, so I get 10G equals 100. Divide by 10, G equals 10. So there's an intercept on that axis at 10, right there. Now notice in this case that I didn't extend the line, and the reason being is that you can't have negative quantities to fit the model. You can only buy positive numbers of hats and gloves. So only the first quadrant here, where G and H are both positive, actually applies. But in terms of a general inequality, you would extend the line and you would also shade. Next thing is you need to figure out what are the possible values that can fit. So now we need to finish the graph. Now when you're graphing these, you're dividing into two half planes. And so the inequality will either be true on one side of the line or the other side of the line. Well, the way you can tell is you can plug in a point. And I usually like to use 0, 0 because that's an easy one to use. So I'm going to put 0 here and 0 here and see if it's less than or equal to 100. Is 20 times 0 plus 10 times 0 less than or equal to 100? 0 plus 0 is less than or equal to 100. That's true, which means I need to shade on this side of the half plane. And normally I would shade the whole half plane here, but because of the constraints, I'm just going to shade this little part right inside. Okay, so any integer coordinate inside here could fit the situation. Like 2, 2 is a possibility, 5, 0 is a possibility, 0, 0 is a possibility. You don't buy anything, or you spend all your money on gloves, so 10 of those. Any one of these is a possibility. And that's why these graphs are helpful, is because it's kind of easier to represent this visually than actually trying to list all the solutions. So that's graphing linear inequalities, and that's the big picture for this lesson.